We take a closer look at the code behind the bouncing logo. As mentioned in the last video, the screen scrolls 1 pixel, then copies 2 rows of logo data from 4000 into 4400. Then it scrolls another pixel and copies 2 more rows, and so on. The logo is copied into screen 4400, but 8 pixels left or right. After register D1016 has scrolled the screen by 7 pixels, we shift the screen to 4400. We then reset the D1016 register and continue scrolling by 1 pixel and copy 2 rows of logo data from 4000 into the next screen at 4C1000. The Cracktro continually swaps screens between 4400 and 4C1000. An algorithm was coded that copied the logo data into the correct part of the screen and padded out the rest with blank spaces. Here, we can see that with an offset of 14, the logo data at 4014 needs to be copied into 4400, and so on. And when the logo has bounced over to the right, if the offset is 14 again, the logo data needs to be copied from 4000 into 4414. Here's the algorithm that needs to be implemented when the logo has bounced to the right. The screen is 28 wide and 28 times logo row just selects which row of the logo to copy into memory. You can see the store command has an extra term to account for the logo offset. We will look at how this was coded now. This piece of code takes 28 and the logo row variable and multiplies them together. The high byte of the multiplication is stored in the 0 page at FC, and the low byte is stored at FB. The next piece of code stores the low byte in 23 and the high byte in 24. We use this for 0 page addressing. Now we take the high byte add 44 and store the result in B1. We then take the low byte, subtract 14, and store it in B0. We must then be careful to update the high byte if the low byte is less than 0 after the subtraction. We now add the offset variable. Update the high byte if the low byte has increased beyond FF. We now have the 0 page addresses set up, and we can use 0 page addresses to load and store data. The highlighted part now copies all of the logo data from the selected row into the screen memory at 4400. It loops until all characters are copied. The next block of code is responsible for padding out the rest of the row with blank spaces. This part checks to see if we have copied the second row of data. If we still need to copy the second row, we recalculate the 0 page addresses again and repeat the process. You may remember the cracking group Fairlight. They cracked a lot of games on the Commodore 64 and Amiga. If anyone knows how to write a Cracktro, it's Bacchus from Fairlight. Here are a couple of their Cracktros. Bacchus from Fairlight was kind enough to give me some coding tips, and in the end, he did a complete rewrite of my code. His code is neat and well planned and works really well. He is obviously a much better coder than me, and it shows. He managed to write a much improved version in which there is less calculating and therefore less strain on the CPU, allowing it to run better. What he did was to define some calculations as to where to read and copy the logo data. You can see that it copies and pastes the data in this routine. A very good solution, and this is what Bacchus's version looks like.